Hi everyone, welcome to Civil Engineering Nated e-learning. My name is Justice Tsetla. Our subject today is Building and Structural Construction N6, and our topic today is steel pipe column. We need to calculate and select the most suitable column that will carry an axial load of 53 kilonewtons. So guys, we all know that an axial load is the force that is acting along the axis or centerpieces of a structure that produce a uniform or same effort or distributed load. So without wasting any time, let's go to the questions and kickstart with our calculations. So now, ladies and gentlemen, we are going to treat question 2. It says a steel pipe column must support an axial load of 53 kilonewtons and the pipe column has a length of 6 meters. And listen, you need to underline that statement. Listen, is effectively held in position at both ends and restrains against rotation at one end only. You need to underline that statement. It's going to help us to find a formula to calculate effective length. So and then they say we must make necessary calculations and select the most suitable column from the given table. So ladies and gentlemen, this is our 3 columns. It's 1, 2, 3. So we are going to use only the size and kg per meter, and then you say 89 by 5.33 as your headings, like this one, and then the second one is 101. You multiply it by 7.29, and then the third one it's 114 multiplied by 8.23 as your headings. So it's like this. It's 1, 2, and 3. You use them as your headings. You don't have to punch a calculator. You use them as your headings. So now, ladies and gentlemen, let's start with our calculations. From the given information, we are given the force of 53 kilonewtons and the length of 6 meters. So we need to calculate. We start by calculating the effective length. So this statement is going to guide us to find a formula to calculate the effective length. So we are going to get a formula from table 17. Sorry guys, it's not table 17, it's table 19. So we are going to calculate the effective length. So let's check now. Check the statement. Effectively held in position at both ends and restrains against rotation at one end only. So let's go to table 19. Can check the statement that is similar to that one. Is this one. Effectively held in position at both ends and restrains against rotation at one end only. So we are going to use this formula, 0.85 times the length. It's 0.85 times the length. So now we start by for us to calculate the effective length, we need to use this formula. It's 0.85 times the length. We are given the length of 6 meters from the given information. So now we are going to say 0.85 times the 6, and then the effective length is 5.1. So ladies and gentlemen, this is our 3 columns. The first one is 89 by 5.33 is this one, this and this, and then again the second one you gotta say 101 times 7.29 is this one. Then the third one you're gonna take 114 times 8.23 is this one. So we have 3 columns now. So we're gonna calculate and select the most suitable one that will support an axial load of 53 kilonewtons. So now we are going to say on this one, we are going to say L over R. L is the calculated effective length, which is 5.1. So now it's in millimeters. Here it's in meters. Don't confuse. So when we calculate here, we calculate it in, you use in millimeters. So it's 5.1 divided by 30.6. And now the answer is going to give you 167. And then you go to this one. Again, you go to this one. So it's L over R. Okay, let me show you where we got this 30.6. From our first column, it's the length, the calculated effective length, which is 5.1 divided by 30.6. This you go this way, and then this is your R. It's 30.6. So that is why I substituted R with 30.6, and then 5.1 it's the calculated effective length. So this calculated effective length, we're gonna use it on all three columns. So it's gonna be, here is gonna be 5.1 divided by 34.9, and it's 101 times 7.29. 101 times 7.29, you go to your R, is 34.9. 34.9, and then 34.9. The answer will be 146.132. And then you go to this one, 114 by 8.23, which is this one. 114 by 8.23. So we're gonna substitute with 39.4. It's the calculated effective length in millimeters, and then you divide it by 39.4. It's gonna give you 129.442. So now we need this answer into, you round it to the nearest 10. It's gonna be 129 here. It's gonna be 146 here. This is 167. So now we are done with this one, and this one. So now we are going to calculate the force. Force equals to PC over A. Okay, if you can check, we only have one unknown here, the PC. The A is there from this column, 89 by 5.33. 89 by 533. 89 by 5.33, and then the A is 0.6786. So you're gonna substitute with this number on A. So we don't have the PC, but the PC this answer will guide us to find the PC from table 17. So ladies and gentlemen, let me show you how to find the PC. The PC is 33 MPa from table 17. And then this number, this answer, our previous answer, the calculated one, is going to guide us to find the PC. And then the A is this one. For first column, 89 multiplied by 5.33. So we're going to substitute the A with this number. And then let's go find the PC. As you can see, I wrote from table 17, and then the PC is 33 MPa. So let me tell you how are we going to select or use this one. If you can check this one, we're gonna use it as 160 plus 7. It's 167. Here it's 140 plus 6, because this one, when we round it to the nearest 10 is 146. So this one, it's 129. Then we're gonna use 129, because when you round it to the nearest 10, it's gonna give us 129. This is 120 plus 9. Here it's 140 plus 6. Here is 160 plus 7. So from table 17, you check. It's gonna be, as you can see, is L over R. Remember here, we have L over R. Ne? So now it's 0 up to 230. Our first answer is 167. So let's go to 160 plus 0. We only use this row. Forget about this one. We only use this. So just forget about this, and then we're gonna use this. Plus 0 plus 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 160 plus 0, 1, 2, 3, 4, 5, 6, 7. 0, 160 plus 0, 1, 2, 3, 4, 5, 6, 7 is 33. So it's 33 MPa. It's 167. It's 160 plus 7. So let's go to 146. It's 140 plus 6. Let's go to this one. It's 140. Then you say 0, 1, 2, 3, 4, 5, 6. It's 42 MPa. This is our answer. Our PC is 42 MPa. Let's go to this one. It's 129. It's 120 plus 9. 120 plus 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is 53 MPa. Mistake, it's 53 MPa. It's 120 plus 9. So now let's go to 120 again. It's 120. Our answer is 129. It's 120 plus 9. 120, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So our PC is 53. So for this one, it's PC times A. PC is this one, the selected one from table 17, and then the A is the area from this column, from 89 times 5.33. 89 times 5.33, and then the area is 0.6786. Then it's going to be PC, which is 33 times 10 to the power 6 times 0.6786 times 10 to the power minus 3. And then you punch this whole thing on your calculator, and then after you press engineering, it's going to give you this answer. And then let's go to this one. This one is 42 from table 17. It's 42 MPa times the A. The A from 101 by 10, 101 by 7.29. 101 by 7.29. Then we need A. A is 0.9293. 0.9293. Then you say 42 by 10 to the power 6 times 0.9293 times 10 to the power minus 3. After you punch this whole thing, then it's going to give you answer. Then you press engineering on your calculator, then it's going to give you this in kilonewtons. We need our answer to be in kilonewtons. That is why we punch it. We punch engineering after. And then let's go to 114 by 8.23. 114 by 8.23. This is our A. It's 1.0490. Then you go to this one. 53 is from table 17. It's 120 plus 9. It's going to give you 53. It's our MPa. So it's 53 times 10 to the power 6 times the A, which is 1.0490, 490 times 10 to the power minus 3. And after you press your engineering, it's going to give you this number. Then let's go back to our question, guys. So guys, so the question says a steel pipe column must support an axial load of 53 kilonewtons. The pipe column has a length of 6 meters and is effectively held in position at both ends and restrains against rotation at one end only. Make necessary calculations and select the most suitable column from the given table. The most suitable one is the one that will carry or support an axial load of 53 kilonewtons. If you can check from our answers, we have 53 kilonewtons from the given information, but we need the one that will carry or support an axial load of 53 kilonewtons. If you can check from these calculated answers, this one is too small, it can't carry 53 kilonewtons. This one too small, but we're gonna use this one because it's 55.5, which is 56 kilonewtons. Then write use 55.6 kilonewtons. This is our suitable force that will support an axial load of 53 kilonewtons. So now, ladies and gentlemen, we have come to the end of our lesson today. I hope you enjoyed and benefited from this lesson today. So for those who have questions, you can place your questions on the comment section. And don't forget to subscribe, guys. Thank you. Bye.